Private data. So what is private data? The idea is simple. Everything you don't want the public to know is private data, like credit card number, banking information, password, or social security number. Even though we are not trying to tell everyone our private information, the back group was still trying to find it out. So how do we protect our information? To hide our information safely, we use the method of encryption and decryption. Encryption is basically scrambling the message to make people don't understand the original meaning. Decryption, on the other hand, is to make the message readable to humans again. First well-known method of encryption happened in 50 BC. The method is named Caesar cipher, named after Julius Caesar. Julius Caesar used to use this method to encrypt the military message to make sure it can be read by the enemy, even if it got intercepted. The method substitutes each letter with a certain amount of steps down the alphabet. The key is the number of the steps, and the one who knows the number can decrypt the message easily. The problem of Caesar cipher is that it is too easy to crack. The only thing you need to do is to try every possible key combination, and there are only 26 letters in the alphabet. That means you only need to try 26 times. It approximately only takes 1 hour for humans to solve the puzzle. And to solve that, you might need to shift each letter by different amount. But in the modern world, a computer or supercomputer can still crack the message in a few seconds. That's why today we develop a really complex key. The key length is getting longer and longer. The most common key now is a 256-bit key, which is 78 digits. It has this many possible combinations shown on the screen. And with a key this long, a supercomputer needs to take 1 trillion years to crack it. But according to Moore's law, the computer calculating speed will double every year. As the computer calculating speed increases, the 256-bit key can one day be cracked. Therefore, the key length must keep increasing. There are two types of encryption mechanism we use today. First, symmetric encryption. Symmetric encryption is when the sender and receiver use the same key to encrypt and decrypt the document. But the internet is such a massive area. We can't always have both sides agree on the same key since sometimes we can meet privately. And it's also inefficient. Therefore, here's another method called asymmetric encryption. The asymmetric encryption means you use different keys for encryption and decryption. A public key is for anyone on the internet to create a secret message to send. The secret message can only be decrypted by the computer with a private key. This is like a mailbox that any person can send a message to. But only the mailbox owner with the mailbox key can open the mailbox and read the message. And the mailbox key is private key. An example of using a symmetric key is the TLS and SSL protocol, which is the HTTPS. The HTTPS makes sure the website is using a symmetric key. Why is it better? Because when you use symmetric key, the website will send a message to the server with the key. Since both user and server share the same key, the website needs to make sure the server knows what the key is by sending the key through the internet. The hacker can usually get all the stuff you send through the internet. In other words, if you use a symmetric key, the hacker can get your key and decrypt your message. So by using HTTPS, the website makes sure you are using a symmetric key. The hacker then will only get an encrypted message.